Welcome to the first of two videos on adding and subtracting rational expressions. So before this, I've already gone over multiplication and division and simplifying. Multiplying and dividing won't be necessarily super important for this, but definitely make sure you have a really good handle on simplifying before you go through anything else. So, adding and subtracting rational expressions. Just like we figured out when we were multiplying and dividing, rational expressions are just fractions. And so if you want to add or subtract fractions, think about that for a second. What do you need to have? You can't just add or subtract any fraction you want. Something's got to be true about them first. We need to have, remember, common denominators. And so that is still going to apply to our rational expressions. The only difference being that our denominators are going to be a lot more complicated, and so getting a common denominator is going to be a little bit more challenging. In this video, I'm only going to be focusing on examples where we already have common denominators. So this is going to be sort of the intro. Once you've got the common denominator, how do you do the adding or subtracting? The getting the common denominators is going to be in the next video, because that's going to be a lot more difficult and a lot more time consuming. So once we have common denominators, say we're doing 5 over 6 plus 11 over 6, how do I add these? Well, step 1, you are going to add just the numerators, so the denominators don't change. So in this case, we're going to do 5 plus 11, both of those over 6, and that's going to get you 16 over 6. Once you've added, all that's left to do is to simplify, if you can. And so it's basically still just going to be those same two steps for our rational expressions. There's going to be some factoring in there to make our simplification possible, but it's still just going to be the same thing. So in this case, we can divide the top and bottom by 2, which is going to get me my final answer of 8 over 3. So let's try it with a rational expression, but we'll keep it pretty simple to start. So if I've got 4 over x plus 1 plus 10 over x plus 1. So my denominators are common. Don't have to think about it too much. So I'm just going to add my numerators. I'm going to do 4 plus 10 over x plus 1. And I wouldn't normally write this step, by the way, but sometimes it is going to be helpful. So 4 plus 10 is going to get me 14 over x plus 1. And there's not going to be anything I can do there. I can't simplify this. So this is just going to stay as is. We do still need to get NPVs though. So for this one, we've got an NPV of x cannot be -1. And then this one's done. That's as far as this goes. Looking at another one. So if we have, say, 8x minus 4 over x squared minus 4 plus 2x plus 8 over x squared minus 4. So to add these, just as a quick refresher for you, we're not going to factor right now. We already have common denominators, so we don't need to worry about that. And we don't want to factor the numerators, because that's going to make combining these much, much more annoying. So don't factor anything at this stage, just add. And to add your numerators, you have to remember to add like terms. So you really got to add these things carefully. So what we've got here is 8x minus 4 plus 2x plus 8. And all of that is over x squared minus 4. So if we combine those, 8x plus 2x is going to get me 10x. -4 and 8 is going to get me plus 4. And that is over x squared minus 4. Now we're going to do some factoring. So we're going to factor both to get our NPVs, because that is still essential, and also to figure out what maybe any simplifying that we can do is. So factor to simplify, and to get NPVs. Up top in this case, we can factor out a common factor of 2, which is going to leave me with 5x plus 2. On the bottom, we've got a difference of squares, so x squared minus 4. That's going to factor to x plus 2 times x minus 2. So in this case, I actually can't simplify, right? I've got no common factors. But I do have NPVs. X can't be +2 or -2. All right, on to the next one. So 3a squared plus 9 over a plus negative 2a squared plus 3a plus 2 also over a. So we're going to add those together. 3a squared plus negative 2a squared is just going to get me a squared. 3a is the only a term, so it's just going to be plus 3a. And then 9 plus 2 is going to get me 11. And all of that is over a. So this actually doesn't factor, right? Nothing's going to multiply to 11 and add to 3, at least nothing with whole numbers. So this one just stays as is, and we get our NPV of a cannot be 0. Where you're probably a lot more likely to mess this up is when you're subtracting, for a very specific reason. So if I asked you to subtract 2x plus 1 over x minus 1 minus 3x plus 2 over x minus 1. Where a lot of people are going to go wrong is they might just write it like this and say, okay, 2x plus 1 minus 3x plus 2 all over x minus 1. And so they would do 2x minus 3x, and they'll get negative x, which is great. But then they'll do 1 plus 2 and get 3. And that's wrong. So when we are subtracting here, we are subtracting this entire second set of terms. And so that means we are doing 2x plus 1 minus 3x plus 2. So what this turns into is 2x plus 1 minus 3x and minus 2. So you've got to remember to subtract everything in your second fraction, in your second term. So this shouldn't be negative x plus 3. What it should be, if we're doing 1 minus 2, is negative x minus 1 over x minus 1. As far as factoring goes, there's nothing to do on the bottom. On the top, we can take out a negative 1. And when we do that, we're going to be left with x plus 1 and over x minus 1. We don't have any common terms here, so we can't simplify anything. And we end up with x cannot be 1 as our NPV. So I'm just going to write out a little blurb for you to add to your notes, just to remind you about that subtraction thing. So you're going to be careful. When you're subtracting, you're going to subtract everything in the second numerator. So with that in mind, try this next one for yourselves. So we've got 4x squared minus 6x plus 3 over x plus 5 minus negative 2x squared plus 4x plus 7 over x plus 5. So pause here, subtract, factor. I will tell you it won't simplify, but it should be factorable, at least to some extent. And then once you're done, come back and see how you did. So I'm going to break this down a little more than I typically would if I was just doing it for myself. So what we've got here is 4x squared minus 6x plus 3. And so that whole thing is being subtracted with negative 2x squared plus 4x plus 7. All of that is over x plus 5. And so when you get rid of those brackets, when you do your subtraction, this becomes 4x squared minus 6x plus 3, right? The first one doesn't change. And then so since we're subtracting negative 2, that's going to become plus 2x squared minus 4x minus 7. Still all over x plus 5. So now if we combine some like terms, 4x squared and 2x squared is going to get me 6x squared. Negative 6x, negative 4x is going to be negative 10x. And 3 minus 7 is going to get me minus 4. And all of that is over x plus 5. So to factor this, up top I do have a common factor of 2, which is going to get me 3x squared minus 5x minus 2 all over x plus 5. And that is factorable. So hopefully you did factor this, and this comes down to 3x plus 1 and x minus 2 over x plus 5. So in this case, it didn't make it something that we could simplify, but it is something you still need to do every time just to be sure. We're left with our NPV of x cannot be negative 5, and this one's done. So all these ones so far, none of them have simplified just because I wanted to really get you a sense of just how the adding and subtracting works. But let's look at some that actually will simplify, starting with a pretty basic one. So let's say we had x squared over x plus 3 minus 9 over x plus 3. So not a whole lot going on here. We're going to do, well, x squared minus 9, even though we can't actually subtract them. And that's going to be over x plus 3. And so this we can factor. So we're going to factor the numerator and the denominator. To see if you can simplify. So that top is a difference of squares. It's going to factor to x plus 3 times x minus 3. The denominator is just x plus 3. And so once you've done the adding and subtracting, once you get to basically here, even at this stage, this basically just becomes a simplification question, the same thing that we would have done back in 6.1 or with the multiplication in 6.2. So now we can cancel out the x plus 3's, and we're left with a very simple answer of just x minus 3. Our only NPV is x cannot be negative 3. And so there we go. That's our answer. So combine, factor, simplify if you can. Let's look at another one. So we've got 4x minus 3 over 3x minus 5 minus negative 2x plus 7, still over 3x minus 5. So subtracting really carefully, 4x minus negative 2x. I'm going to skip some steps here and just do the subtraction in my head. So if you subtract a negative, that's adding. So this is going to become 6x, right? 4 minus negative 2. And then we've got negative 3 minus positive 7. So that's going to be negative 3 minus 7, which is going to get me minus 10. Up top, I do have a common factor of 2. So when I take that out, I'm left with 3x minus 5, which is going to cancel out with that 3x minus 5 I have on the bottom to give me my final answer of 2. And my NPV is 5 over 3. All right, last one. This one's going to be for you to do, and as I often do, I'm going to make it a little bit more difficult just to challenge you. So do everything you can with this one. You're going to add, you're going to subtract, you're going to factor. It is going to simplify at least a little bit. So take your time, go through it slowly and carefully. Make sure you do your NPVs at the end. And once you're done, check in to see how you did. So pause here, give it a shot, and then come back in a bit. All right, so combining my like terms. I've got 2x squared plus x squared, so that's going to get me 3x squared. I've got 13x minus 2x, so that's going to get me 11x. And then I've got negative 15 minus 5, which is going to get me negative 20. Over x squared minus x minus 30. So now I need to factor this. So I'm going to factor the bottom one first because it's a little bit easier. So multiplying to negative 30, adding to negative 1, that is x minus 6 times x plus 5. And so I'm just going to use that sort of, not as a guide necessarily, but something to keep in the back of my head. So as you factor this one up top, where we have that a value and you've got to do all the extra work, just think, maybe you're going to run into an x minus 6 or an x plus 5. It's not a guarantee, but at least there's a chance they might pop up. And they will. So once you factor this, you'll end up with 3x minus 4 times x plus 5. So we do have that repeated factor. If you didn't get that, it's a good chance you might have messed up somewhere along the way. So we cancel out the x plus 5's, and we're left with 3x minus 4 over x minus 6. And our NPVs are positive 6 and negative 5. And so there you go. That is how you add and subtract once you already have common denominators. But obviously, a lot of the times we don't have those common denominators. So once you think you've got a handle on this part of things, go ahead on to the next video and figure out how to add and subtract once you do need to find a common denominator. Fair warning in advance, it is going to be a little bit more difficult. So once you're ready, go take a look at that.